In this video, we're going to go over the C2 Topic 1 Reactivity series past paper questions. So this first question looks at the reaction of zinc with steam. So the damp mineral wool is there being heated, so that will turn the water into steam. And then the zinc and steam, or hydrogen oxide, gives us zinc oxide, which will stay here, and then the gas that will pass over there is hydrogen. So zinc and hydrogen oxide giving us zinc oxide plus hydrogen. So the gas produced hydrogen, the damp wool was being heated to make the steam or to generate the steam. The colour of the solid produced from the zinc, well, that would have been zinc oxide. Now, outside of copper compounds, all other compounds that we come across are white, really. So white would be the answer. Metal other than zinc that'll react with steam but not with cold water. Well, those ones that react with steam but not with cold water in the middle of the reactivity series. So iron, zinc, magnesium, even up to aluminium. Magnesium's a group 2 metal, so 2 observations when magnesium is burnt in air. So we get that brilliant white light every time magnesium reacts. It leaves a white solid, the magnesium oxide, and then it's obviously an exothermic reaction. The symbols equation, Mg plus O2. Now keep in mind that we have to work out the formula. So magnesium atoms, Mg, is group 2, so plus 2. Oxide would be an oxygen atom, O, and then it's in group 6, so minus 2. So Mg plus 2, O minus 2 means the formula is MgO. Now take your time and work that out. Don't just follow on from here. Common mistake is just write MgO2 because we've got those two things over here. So take your time, work out the formula, and it's MgO. Once you do that, then balance it. So 2 oxygens, so 2 in front of the MgO to balance it. That now means we have 2 magnesiums, so 2 in front of the Mg. This next question has got a table with a series of reactions. Now, any of these reactions where we see an observation, in other words, a reaction's taking place, that means that the metal is more reactive than the metal that's with the salt. So the metal is displacing a less reactive one. So in this case, copper is more reactive than silver, and it's displacing silver from silver nitrate solution. Where a reaction doesn't take place, then this metal must be less reactive than the metal sulfate or nitrate that's given there. So you can see in this one here, we've got iron not able to displace zinc, so that means zinc is more reactive than iron. Silver isn't able to displace iron, so iron is more reactive than silver. Zinc and copper sulfate solution, so the zinc is able to displace the copper. We've got a blue solution there, so then that's giving us zinc sulfate plus copper. And this one, iron and copper sulfate solution, and we see again blue solution being formed there, so that must mean that the iron is displacing the copper. So copper more reactive than silver, so we'll put that in the table later. Zinc more reactive than iron. Iron more reactive than silver. Zinc more reactive than copper, and iron more reactive than copper. So we'll put that in the reactivity series shortly. So the solid formed when iron reacts with copper sulfate solution, so that must be the copper, isn't that right? So iron and copper sulfate gives you iron sulfate, that would be the solution, plus copper, and copper is a brown solid. They would accept brown or red brown as copper. Possibly sometimes they might even accept black. That's less likely because it's usually think of copper as a brown solid, so put that down. But yeah, when copper gets heated, sometimes it do get a black colour there, but brown solid is the main one to look for. Then why did the colourless solution turn blue when copper reacted with silver nitrate? Now, the word equation would have been copper and silver nitrate would have given us copper nitrate plus silver. So the blue, do you remember, is the copper nitrate. Do you remember copper salts? We talked about that with acids and bases in C1. All copper salts in solution are blue. So the blue solution must have been the copper nitrate. So copper nitrate was formed and copper salts are blue in solution. So the order of reactivity, well, of the 4, do you remember zinc was always more reactive than the others, so it goes to the top. Iron was more reactive than copper and silver, so it would go next. Then copper was more reactive than silver, so it would go next. And silver was bottom of the reactivity series. And then which of the metals, copper, iron, silver, zinc, would you expect to react most quickly with dilute hydrochloric acid? Well, it's the one at the top of the series, so it's this one here, zinc. And the reason being is the most reactive. Okay, So that's the past paper questions.